Recall that when we were graphing equations, we found it was very useful to identify symmetry in equations because it reduced the amount of work in graphing. And so if we replace x by minus x in an equation relating y and x, and the equation remains the same, then we know the graph is symmetric with respect to the y-axis. And if we replace x by minus x and y by minus y and the equation remains the same, then we have symmetry through the origin. And so for a function f of x, this amounts to saying that if we replace x by negative x in the formula for f, and suppose f of x equals f of negative x, then the graph is symmetric with respect to the y-axis, and it's called an even function. And if f of x is negative f of negative x, then it's symmetric with respect to the origin, and it's called an odd function. Now, of course, there's no reason for either of these two things to happen, but if they do happen, then it's enough to draw half of the graph. So let's see if we can identify whether this is either even or odd, and if that'll help us to graph the function. So let's see what happens when we replace x by negative x here. Let's do that with a black pen as opposed to a green one. So f of negative x here is negative x cubed plus negative x. And that's negative x cubed minus x, and that's minus x cubed plus x, which is minus f of x. So now that's situation 2 here. So this is an odd function, and that's just another way of saying that we have symmetry through the origin. Okay, so then it's enough to draw this function for x greater than 0. So let's plug in a few points. We have, when we take x equal to 0, we get 0, so the point 0, 0 is on the graph. We take x equals 1, we get 2, so the point 1, 2 is on the graph. And when we take x equals 2, we get 2 cubed, which is 8 plus 2, so we get 10 here. So this is way up here. Should have anticipated that. And so we get something that looks like this. It's like the x cubed function, but it's a bit steeper because you're adding x to it. And now because it's symmetric in the origin, the other half looks just like that too, except it goes the other direction. So we get something that looks like x cubed, but it's a bit steeper. The point here is it's enough just to draw this part and use the symmetry through the origin to draw the other half of the function. What about g of x when we replace x by negative x? We get the absolute value of negative x and negative x squared plus negative x squared, sorry. And that's the same as the absolute value of x plus x squared. So that's actually equal to g of x. And so now it's an even function, and we have symmetry in the y-axis. So again, we can just draw the right half of this graph, and then we fold over to get the other half. So when x is 0, y is 0 here. When x is 1, y is 2 again. It's the point 1, 2. And when x is 2, we get 2 plus 4, which is 6. So again, this one looks like this. It's kind of like the parabola y equals x squared, except you're adding x to it, so it distorts it just a little bit. And then the other side is a copy of that by reflection in the y-axis. So we don't really need to get points here. We know that this is just a reflection of this one in the y-axis. So this is our graph of y equals the absolute value of x plus x squared.